Alright, so I'm going to go over these to review. So the first thing is they're asking you about a titration, very similar to your lab. So like if you look here, basically it's a titration problem. You have an acid and a base. It says use method 1, which basically is going to be this. MAVA is equal to MBVB. Then you have to pay attention to the number of OHs in the base and the number of H pluses in the acid. So the first thing what we're going to do is we're going to take a look. If I notice, the first thing I see is there's two OHs there, so I'm going to put a 2 there. I notice that there's one H there, so I'm going to put a 1 there. Now, volumes. When it's given to you like this, remember final minus initial, just like your lab. You can take 18.75 minus 0.10, so I'm going to end up with 1865 decimal there, ml, for my volume of my base. If I look at my molarity of my base, it's given to me in the table, it's going to be 0.1, goes right there, equals, and then what I'm going to end up doing is I'm going to end up figuring out what my volume of my acid is. So I'm going to just go 16, so I'm going to do 16.12 minus 2.51. Ultimately, I get 13.61, so my volume is a little crunched, 13.61, and I just pop an X there. So then on this side of the equation, the molarity of the base, 0.1 times 18.65 times 2. This is 1 times 13.61. You divide on the other side, and you solve for the molarity of the acid. Now, that's the first one. But look at the next one. If I look right here, I'm going to clear that off. This work. So if I go like this, we capture this. Capture these two. So we'll do this. So if we look, I'm going to do this one. So if I take a look at this, so I go to do the top one, right? So the first thing I do is I'm going to do this. Same idea. It's the exact same thing. It's method 1. So I'm going to go MAVA is equal to MBVB, number of OH minuses, number of H pluses. So when I go and set it up, basically what I do is this. Notice how many OHs I have there. I have 3. I have 2 H's there. Pop into 2 there. Then I'm going to basically, I need my volume. So the first thing I'm going to do is do the final minus initial. So I'm going to go 19.96 minus 0.35, and I end up with 1961 is the volume of my base. My units, milliliters. The molarity is 0.121. There's my setup there. It equals volume of the acid. I'm going to do 17.13 minus 2.78. I'm going to get 14. So my volume of the acid is going to be 14.35. Pop an X in there. I'm solving for X. And there's your setup, and you end up getting that. Sig fig wise, just look at the least number of sig figs. The least number of sig figs is going to be trace. So that's why you get 3 right there. Next, if I look at this one, so method 2 it says here, method 2. Think of it this way. Notice how these two are given together, and this one's set on the side, and ultimately you need to find molarity, right? So let's think of it like a grid problem. So the thing all I'm going to do is this. Is I'm going to make a grid, and I'm going to do this. The values, these two are given together, so I'm going to do this. I'm going to take this value that's in milliliters. Milliliters is never good in a grid, so I'm going to change it to 0.07285 liters, and that is KOH. Then I'm going to use the molarity next because I have liters here, so I'm going to pop in the molarity, and when it says it's 0.7500 moles of KOH divided by 1 liter, because that's what molarity is. So I just pop these two right in the grid, changing that to liters. Now I got moles in the upper part of the grid. I just do stoichiometry. My ratio is right there. It's a 1-to-3 ratio. So moles of KOH is here, so moles of KOH has to go down here. 3 moles of KOH is equal to 1 mole of H3PO4. Now, at that point, I'm going to stop. I'm going to just run the grid. The last thing I have to do to get molarity of the other one, when I run this, I'm going to see what this comes out to be actually. 0.07285 times 0.75 divided by 3. I end up getting 0.01821. So I get that because I got 4 significant figures coming into the grid. It's got to be 4 out. I take this sucker right here. To get molarity, it's moles. I just got moles. I just put liters on the bottom. So I change the milliliters to 0.03500 Divide that by 0.03500, and bam! You get your answer. Whoop, whoop, whoop. Right there. There's your answer. Piece of cake. Piece of cake. Next one. Next thing they ask you. Let's see here. This is going back to pH line. It says, what is the pH of a solution? So if you look right here, it's asking me, what is the pH of a solution? So if I go here, how do I switch back out of there? Switch. So I'm going to switch here. Alright, so number 4. When you look at number 4, basically, it's just asking you the pH of a solution. Notice there's no Ka or Kb. Because think about it like this. It goes back to the original idea of pH line. If you remember pH line, what you're doing is you're given an HCl, you're given one of these, and you got to basically find other numbers. So no Ka means you go right to pH line when they're asking you pH. It's a simple problem-solving solution for you. So if we look right here, it says, dissolving, what is the pH of a solution dissolving 0.216 NaOH in 165 solution? So I take 2.16 grams of NaOH. I'm going to divide by the molar mass of NaOH, which is going to be 40.0 grams of NaOH. And I am going to get, that's equal to 1 mole. When I do that, I am going to get, divided by 40.0, I'm going to get 0.00540 because 3 sig figs here, boom, 3 sig figs there. Now, to get the molarity though, remember, because to get to pH line, I have to start with molarity. I take the milliliters, I'm going to change them to liters, move it over 3 places, so I'm going to get 0.165 liters. So I take that divided by 0.165 liters. I get a molarity of OH minus that is going to be 0.0327 OH minus. Then I go back to pH land. So if I'm 0.0327, I go here. If I think about it like that, I'm starting out with 0.0327. It's asking me the pH. So the first thing I'm going to do is I'm going to take the negative log of that. So I'm going to go 0.0327 log, and I get 1.485. The reason why is whenever you take the log of something, remember the sig figs don't start till after the decimal. So I get that, then I just do 14 minus that. So I'm going to go 14 minus 1.485, and boom, I'm going to get 12.515. Right there, again, started with 3 sig figs on top. Decimal places has to be the same. Decimal places are sig figs from the top. And you get that, and the answer is, boom, that. Next, 5. Hydroxide ion concentration. You have ammonia, which has a pH of this, so 12.15. So where are they starting me with? No K, no KB, really. It's just give me pH is 12.15 here. First of all, I got 2 decimal places, which means I'm going to have 2 sig figs on top. You want to be aware of that. First thing I'm going to do is I'm going to go over to POH, so I'm going to just go 14 minus 12.15, and I'm going to get 1.85. Mathematically, to hop up there, it's just 10 to the negative 1.85. So I'm going to go 10y 1.85, and I'm going to end up with 0.014 is going to be my molarity of OH. So if I look right there, and I look right there, another one right, piece of cake. Now, hydronium concentration, where the hydroxide ion concentration is this, acidic, basic, or neutral. That you need pH for to tell that. And hydroxide is 1.56 times 10 to the negative 8, which means in pH land, I'm starting in the upper right, 1.56 times 10 to the negative 8. Remember, H plus times OH minus across the top is equal to 1.0 times 10 to the negative 14th. So whenever I want to solve for whichever, I just drop the other one underneath. 0.56 times 10 to the negative 8. So I'm going to go 1.0 E 14 negative divided by 1.56 E negative 8. I end up getting, wait for it. Caramba, I just erased it. So I get 1.0 times 10 to the negative 14th divided by 1.56 E. I get, remember I started with 3 sig figs, so across the top it stays the same, 6.41 times 10 to the negative 7. That doesn't give me pH because pH I have to take the negative log. If I take the negative log of that sucker, I get 6.1 193. Remember, decimal places on the bottom, which makes that an acid. So that would basically be considered an acid, and there is your H plus concentration. Now, whenever you see a Ka or a Kb, this is the first thing you think of. It's x squared over molarity. If it's Ka, that means x is the same thing as H3O plus. If you get Kb, x squared over molarity, when you see the B there, it means base, which means x, when you solve for x, you're going to get OH minus. But then, whenever you have to find pH or anything like that, you have to go, this just gives you the starting point, then you go to pH land. So it's a two-step problem. So whenever you see a Ka or a Kb, first thing you got to do is use the equation. So you're going to use the equation right here to solve. Then you're going to go to pH land. So let's take a look here. It says Ka. So the first thing I know is x squared, move it over there, x squared over molarity is equal to Ka. So then what does she give me? She gives me Ka, and she gives me molarity. So I'm going to solve for x squared. So I'm going to just go 0.425 equals 1.8 times 10 to the negative fifth equals x squared. So what I'm going to do, bust out my calculator, 0.425 times 1.8 e5 negative. I get, I'm going to take the square root of it. X comes out to be 0.00, let's see here, comes out to be 0.0028, we'll say. Okay, that's what I get when I solve for x. Remember, that is when it's Ka, that's H3O plus. So I'm going to take that 0.0028, I come over here, I'm going to gangster it up, I go, that means this is 0.0028. My last step now, I can enter pH land, I'm going to go 0.0028, take the negative log of it, bam, and I get 2.55 is my pH. And that's how it works when you see a Ka or a Kb. Whoop, whoop. Boom, piece of cake. Piece of cake right there, 2.55. Let's look at the next one. First thing I see, brown bear, brown bear. What do I see? I see a Kb looking at me. So I'm going to go x squared over molarity is equal to Kb. My Kb is going to be 1.77 times 10 to the negative fifth. Little molarity action, 0.617 x squared. Remember, Kb means that gangster is going to be OH minus when I'm done. Then I go to pH land. So let me bust this out. So what I'm going to do is I'm going to go 0.617 times 1.77 e5 negative. Boom. Square root. My x comes out to be 0.00330. That is my OH. So I go to pH land. What is it? So I'm going to go here to my pH land. That means 0.00330. Then all I'm going to do is take the negative log of that. Remember, I have 3 figs, so when I start my decimal places, my POH is going to be 2.481. That ain't pH. I have to subtract from 14, then I get pH. So I go 14 minus that, so 14 minus 2.481, saved by the bell. 11.519, yo. 3 decimal places because it started with 3 significant figures. And let's take a look. Piece of cake. That's the first side of the worksheet. All right.